All right. All right, our agenda today. What are we going to do? We'll do questions, homework, or otherwise. We'll talk about the test format. Then we'll take the quiz, or when you finish, you can work on the review. But that's going to be that'll be the plan for today. Sound okay with you guys? Okay. Correct. Questions on stuffs. Can be specific homework, could be stuff in general. Okay. So let's just recap here then. So you have these three cases, or three types of problems that always just have one triangle, right? You have the side, 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 which can have 0 or 1. But the check there is really easy. What do we do to check that one? Yeah, some of the legs has to be bigger than the hypotenuse. And then there's the SSA situation where a bunch of different things can happen. So the first thing we have to check is the size of the given angle. So either that given angle is bigger than 90 degrees or it's acute. Okay? If it's bigger than 90, if that given angle is bigger than 90 degrees, two things can happen. You can have one triangle, or you can have 0 triangles possible. Those are the only two outcomes. If it's one triangle, the side opposite the given angle has to be greater than the other given side. Otherwise, there's 0 triangles. If our given angle is less than 90 degrees, there's two situations. Either you have one triangle or you have this ambiguous case. So if the side opposite the given angle is the shorter or is less than the other given side. I don't know why I wrote side here. This should be given. Then you're in that ambiguous case situation. Otherwise, you have one triangle. Now, Kendall, to deal with this situation, say that angle A, and side B are the givens. To tell what's going on, we set up a law of sines. And we solve this for sine of B, not angle B, but sine of B. And then this value is going to tell you whether you have 0, 1, or 2. So if that number is greater than 1, you have 0 triangles. If it's equal to exactly 1, then there's one triangle. And if it's less than 1, we have 2 triangles. Okay? And did you want to see a specific 2-triangle situation?
Yeah.
Okay, let me just steal one from the problems here. I'm just going to do one of these that are guaranteed to be two triangles because they're not like trivial to make up an instance. So I'll just do 11. Okay? So 64, 16, 17. Okay. So let's already say we went through the rigmarole to figure out this is the ambiguous case. Are you okay with that?
Yes.
Okay. So what I'm going to do is we'll start by setting this up. So I have my area to work on, triangle 1. I have my area to work on, triangle 2. Maybe I'll write it triangle 1, triangle 2. That's a little bit more natural. We're going to have to solve for angles B, C, and side C. So we'll get 2 sets of answers for those. The givens are true in both triangles, though. So to solve for angle B, I'm just going to set up my law of sines and solve for angle B. So I'll cross multiply, divide, and then take the sine inverse. Kendall, is it okay if I do that kind of all in one shot? Yeah, there's just this algebra. Okay. So 72.74 for angle B1. Now in triangle 2, there's a relationship between angle B1 and angle B2, in that those two angles need to be supplementary. So that's going to be what? 107.26. Now that I have angles A and B, I can just do like a triangle sum thing to figure those out. Oops. So 43.26 for this one. And 8.74 for the other one. And now we just have to calculate side C. To do that, I'm going to just set up a law of sines using angle C. But remember that angle C is different in each triangle. So again, solving, we're just going to cross multiply and divide. So 12.20 for the first triangle, and my value for side C in the second triangle is going to be a lot less, like 2 something probably, 271. Does that feel okay, Kendall?
Yeah.
Enough detail for you? Okay. Again, if there's stuff that you missed or you need me to fill in or explain why, I'm happy to do that. Just speak up or whatever, and I can elaborate. Okay. That goes for anybody, right? Whew. That was one heck of a question there, Kendall. I talked a lot. That's okay, I talk a lot. Helps when you're specific, right? Math isn't one of those things where it's just like, yeah, whatever. You know. Helps if we're specific. Others, anyone else? That's the single hardest thing we have to do, is to sort out that situation, right? Or at least longest. Maybe it's not hardest, but. Okay. Going once, going twice. Anybody else? Okay, let's talk real quick about the test format. Drop that in here. So this is the format for the test. So the first 4 questions are just asking you to solve the triangle. So you need to identify the situation and select the correct method. One question where I tell you there are 2 triangles for this problem, and I need you to solve both triangles. Similar to the homework problem that we just did there, where I knew it was 2 triangles already. 2 questions where I ask you to find the area for the triangle. And then there's 2 story problems where you'll just, to find the length or whatever requested in the story problem, you can use the law of sines or cosines. Nolan?
They get the area for it, right?
Yes, yeah. So on the, let me double check here. Usually I have, yeah. So if you look on the last page of the review, contains the formulas that you'd get on the test. And that's usually always the case. At least that's what I plan to do every time, but sometimes I guess I might have messed that up, but I think it's always that way. Joe?
So for like law of cosines in the area of a triangle, if you're solving for like a different variable, you can just switch them around. So like for area of a triangle, if you had the angle of A, you can just do 1/2 B times C times the sine of A, right?
Yeah. Yeah.
And the same goes for law of cosines. Like if you're solving for C,
yeah, so like if we have this situation where it's like, oh, I know this, this, and this. No, that was a bad choice. I know like this, this, and this, and I'm trying to use that area formula. Well, I'll just rename this as A, and then like this is B, and that's A, and then I can just, formula is what it is.
Yeah.
Is that, you know what I mean?
Yeah.
So you just make appropriate substitutions and you can relabel things, and that's fine. As long as the side length name is always opposite the angle name, right? That B is across from B, A is across from A, C is across from C. As long as you do that, that's fine. Yep. That's why I just gave one version of the formula.
Yeah.
Cool? I'm going to erase that out of there because that was in the review. I didn't mean to be writing there. All right. And on these two story problems, here's the added bonus. One of the story problems is going to be a same story problem you've seen before from a previous section that was like a giant pain in the tuchus because you had to like solve a system to get it, when instead we can just use like law of sine or cosine and it just like can go directly to our answer, and it stumbles kind of right out at us, which is super nice. Anyways, any questions on the format here? Again, the test day is Tuesday. That sounds right.